Hello students, welcome back to my video. We have started the chapter number 10, that is visualizing solid shapes. Okay, so we have explained already the chapter and we have done the exercises, right, and given the homeworks also. So today in this video you will see all these shapes you have seen. They are polyhedrons and pyramids and prisms, right? Now do this, and this one you have to understand nicely. Why? Because in every solid figure there are faces, edges and vertices. So tabulate the number of faces, edges and vertices for the following polyhedrons. Here V stands for number of vertices, F stands for number of faces and E stands for number of edges. Okay, F, V and E. And here it is written F plus B, that means you have to add the face and vertex, and here E plus 2, that means edge plus 2. Now here you have to write number of face, edge and vertices in cuboid. So in cuboid there are 6 face, 8 vertex and 12 edge. Triangular pyramid 4 face, 4 vertex, 6 edge. Triangular prism 5 face, 6 vertex, 9 edges. Pyramid with square base 5 face, 5 vertex, 8 edges. Prism with square base 6 face, 8 vertex, 12 edges. Now you have to add here and write the result. Now see, after adding, what is the result coming? So F plus V, that means face and plus vertex is 14, and here edge plus 2 is also 14. Here you can see both the quantities are equal. Okay, F plus B is equal to E plus 2. Here also it equal 8 plus 8, 8 and 8, 11 and 11, 10 and 10, 14 and 14. So these two relations are equal to each other. So these two relations conclude one new type of theory, one new type of formula. So let us see what is it in the next page given. So you can see here in the next page, what do you infer from the last two columns? Okay, the last two columns of that table, what do you infer? What is the conclusion? In each case, do you find F plus V is equal to E plus 2, right? So these two things are equal to each other. F plus V is equal to E plus 2. That is F plus V minus E equal to 2. So when you bring this E this side, so it is F plus V minus E equal to 2, right? So this relationship is called Euler's formula. See, this is a new type of formula. This relation is known as Euler's formula. Okay. So in fact, this formula is true for any polyhedron. So this formula will be true for all the polyhedron. Understood? So you have, in the questions, you have to check by that formula if it is a polyhedron or not. Okay. Now let's start our exercise 10.3. So can a polyhedron have 4 its faces? So you have to say whether it is true or not. So question number 1 is, can a polyhedron have for its faces 3 triangles? No. 3 triangles cannot have 4 its faces. 4 triangles, yes. A square and 4 triangles, yes. Okay, so simply you have to write here yes or no. Now question number 2, is it possible to have a polyhedron for any given number of faces? Okay, it is possible. Yes. So how to write it? So here you can see the question number 2 answer is yes, it is possible only if the number of faces are greater than or equal to 4. Okay, then only it will have a polyhedron. Understood? Now question number 3, which are prisms among the following? So here 1, 2, 3, 4, 4 figures are given. One nail, then unsharp pencil, table weight and box. So which of these figures represent a prism? So you can see prism has polygonal base. Okay, that means pentagon, heptagon, square, rectangle. So here you can see this is prism and this is prism. So 2 and 4 are prism, are representing prism. So now understood. So 2 number and 4 number is the prism. Now question number 4, how are prisms and cylinders alike? That means you have to write the similarity between prism and cylinder. And second is, how are pyramids and cones are alike? So I will write the answer. Let's see. Now here you can see question number 4, how prism and cones are alike. That means what is the similarity, how a prism can become a cylinder. So a prism becomes a cylinder when the number of sides of its base. So whose number of sides? Prism number of sides. Okay, number of sides of its base becomes larger and larger. Understood? Then the prism will become a cylinder. Next question is how the pyramid and cones are alike. What is the similarity between pyramid and cone? So how pyramid becomes a cone? Pyramid becomes a cone when the number of sides of its base, again same thing, like prism, number of sides of its base becomes larger and larger. Same answer, right? So this is question number 4 answer. Now question number 5, is a square prism same as a cube? Explain. So what is the answer? So the answer is no. Okay, so it can be a cuboid also. Understood? So is square prism same as cube? No, it is not true. Okay, so it can be a cuboid also. Now question number 6, verify Euler's formula for these solids. So you can see two solid figures are given here. You have to verify the Euler's formula that you have seen just now. The Euler's formula in the top here you have seen. This is the Euler's formula, f plus b minus e equal to 2. So you have to check like this. LHS equal to RHS, you have to check. For these figures, you have to take out the what are the number of faces, what are the number of edges are there. Then you have to put in the formula and you have to check it. So you can see, first of all you have to make the diagram nicely. So here in the back side also you have to make the line. Okay, so this is one edge, then this is other edge, and this is other edge. So now you have to count the number of faces, number of edges, number of vertices, and you have to put in the formula. So now see how to verify the Euler's formula. Here you have to write one by one everything. Number of faces f equal to 7, number of vertices b equal to 10, number of edges e equal to 15. Now according to Euler's formula is f plus b minus e equal to 2. That means you have to prove it, that is coming to 2 or not. So you have to put all the values. F is 7, v is 10, e is 15. Now it is 17 plus 15 is 2. So here also 2. That means LHS and RHS are equal to each other. That means it is verified. So hence verified. So you have to write like this. Now here in question number 2, so this is also one type of polyhedron. So you have to count the number of faces, edges and vertices. Now after that, see how to write it. Number of faces f equal to 9, vertices b equal to 9, edges e equal to 16. According to Euler's formula, f plus b minus e equal to 2. So face is 9, vertex is 9, edge is 16. So 9 plus 9, 18, 18 minus 16, 2. Here also LHS equal to RHS. That means it is verified. Okay, understood? Now let us do question number 7. Using Euler's formula, find the unknown. So here you can see this table is made. Face, vertex and edges are given. So these are face, these are vertex, and these are edges. So you have to find the unknown number, unknown quantity. Here face you have to find, here vertex you have to find, here edge you have to find. So how can you find it? By using the Euler's formula. So let's do it. So here you have to find the faces. Vertex is given 6, edge is given 12. So for this first case you have to find the f. Second case, here you have to find the v. Third case you have to find edge, that means e. So let's find it. Now here you have to write the formula, f plus b minus e equal to 2. This is the Euler's formula. Now I have to put the value of b here 6, e is 12. Okay, now this is our equation. You have to find the value of f, that means face. So let's do it. So here f plus, so here 6 minus 12 is minus 6 equal to 2. So f equal to, this minus 6 will go this side. So 2 plus 6, it is 8. So the face has come 8. Understood? So this is the way of doing question. Now here find out the vertex b. Okay. Now see, this is, you have to find here b. So face is 5, edge is 9. So 5 minus 9 is minus 4. So b equal to 6. Now here in this case you have to find the edge, that means e. Now here in this case you have to find e. So face is 20, vertex is 12. So 12 plus 20 is 32, e equal to 30. Okay. Now question number 8. Can a polyhedron have 10 faces, 20 edges and 15 vertices? So how to check it? By putting all the values in the Euler's formula. So if it is coming 2, then it is true. If it is not coming to it is not true. So you can see here how to check it. Here face equal to 10, vertex equal to 15, age equal to 20. So you have to check by the Euler's formula. So you have to put all the values in Euler's formula. It should come 2. So f plus b minus e, 10 plus 15 minus 20. So it is 25 minus 20 is 5. So it is not equal to 2. LHS is not equal to RHS. So the answer is no. Okay. So in this way, the exercise 10.3 is complete, and this chapter visualizing solid shapes is also complete. So please do all the questions and practice all the questions. Thank you.